All right, in this lesson, we're going to talk about solving radical equations. Remember, radicals are our square root or cube root, and we may even find some other roots type of equations. So the first thing I want to show you is just what the solutions look like on graphs. So this first example is just showing you what would it look like if you had a radical. We're solving this problem right here, a radical and a line. So that's what this is. This is a radical. It's a square root function. 2 is just a regular line. So if I draw that line here, I want you to see that they're going to cross in one point. So this is going to give us one solution. Now, if we look at some other types of equations, we can see, that we have some other options. For instance, this example C at the top, the right side is going to give us a radical equation. So it might look something like this. And this other side is a line, but it's not like a horizontal line anymore. That's x plus 1, which you would start at 1, up 1 over 1. So there's a few different options there. If you have a radical and a line, they could intersect in two places, right? Or they could intersect, intersect not at all, right? I could have a line that looks like this and doesn't hit at all. Or the other one, it looks like they're going to intersect in two ways, but let's look at a line that looks like this. Notice that since this radical stops, there's really only going to be one solution for that type of function. The last option is if we have two root equations, that's going to be, and they can go like different directions, but two root equations can intersect in a whole different set of options too. So let's look at how we solve these, because we're not necessarily going to use our calculator, but I want you to understand that there are some different options for the number of solutions we can get. All right, so the instructions here say to solve the equation and check for extraneous solutions. We're going to talk about what this means here in just a minute. So if you remember from those examples I just showed you on the graph, the first thing we want to do is get this radical completely isolated. So that's your first step always, is to isolate the radical. So I'm going to have square root x plus 10 equals x minus 2. So I'm going to subtract 2 from both sides. Now, when I do that, notice I've got a radical and a line, so we've got a few different options for how those can intersect. To undo this square root, we're going to square. All right, so I'm going to square both sides. Notice that when I square this this right side over here, I'm squaring the whole thing, not just each individual term. All right, so on the left, I'm going to have x plus 10. On the right, remember when you square this, you've got to write it out. X minus 2 times x minus 2. You can't just square each part separately. When I work that out and simplify, that's going to give me x squared minus 2x plus 4. Actually didn't simplify yet. Now to solve, now we're looking at something that's x squared. This is a quadratic, and remember to solve, we need the quadratic to equal 0. So I'm going to move this this x and this 10 term to the right side. That's going to give me 0 equals x squared minus 5x, right? Because I had minus 2, minus 1, and then minus 6. All right, and now you want to think about if you're looking for solutions or to solve, this right here is quadratic, and the easiest thing to always do first, if we can, is to factor. That's always going to be what you should look for first. So negative 6 is my top number, negative 5 is my bottom. Let's see, those two numbers are going to be negative 6 and 1, so that's going to give me factors x minus 6, x plus 1, which is going to give me solutions of x equals 6 and x equals negative 1. Now, remember the directions up here at the top said to check for extraneous solutions. That has to do, I'll show you kind of what that looks like here in a minute, but we want to just plug it back into the original equation and make sure that what we're getting is going to work. So if I do that, let's plug into the first one. Let's see, I'm going to do negative 2 plus the square root. 6 plus 10 is 16 equals 6. All right, I'm just plugging into that original equation. So that's negative 2 plus 4 equals 6. And I copied that wrong, sorry, that's a positive 2. All right, so that's going to give me 6 equals 6, which means this is a solution. Now, if I check this other side, negative 1, I have 2 plus, negative 1 plus 10 is 9, equals negative 1. That's 2 plus the square root of 9 we know is 3. Now this side, notice this side gives me 5 equals negative 1. That's not a true statement. That means negative 1 is not a solution. So the only real solution here is going to be this x equals 6. Now graphically, just so you can kind of make sense of why it looks like there's two answers, but there's really only one, 6 up here is where they're actually crossing. This -1 would have been if this would have been a complete parabola, but remember square roots only go one direction. So since they only go one direction, this is going to look like a solution, but it's really not going to be a solution. So I just wanted you to see and understand why sometimes there are one and sometimes there might be more than one. All right, now the second example looks a little different to begin with, but it's actually not all that different. The first thing I want you to know is this 1/3 right here. You haven't seen that before, but that really is the same thing as cube root. And we'll talk about that more in depth in a different lesson, but just know that that's the same thing as cube roots. The first thing I'm going to do is rewrite this. The cube root of x minus 5 equals x plus 1. So very similar to square root. To get rid of squares, we square the number. To get rid of cube roots, we're going to raise the number to the 3rd power. So I'm going to do the same thing. This time my cube root is already by itself, so I don't need to move anything. When I raise that to the 3rd power on the left side, those are going to cancel. Cube root and cube cancel each other, so that's just x minus 5. On this right side, we need to expand this. All right, so let's use our little trick here. We've got 1, 3, 3, and 1. And then I'm just going to count down for my x's, x to the 3rd, x squared, x to the 1st, and then nothing. And then I'm going to count up for my 1. So the first is 1 to the 0 power. This is times 1 times 1 squared times 1 to the 3rd. 1 to the 3rd. All right, and then if I simplify that, that's just going to give me all together x to the 3rd plus 3x squared plus 3x plus 1. That was a pretty simple one. Now again, we're trying to solve the same way we solved all polynomials. We need them to equal 0. So if you haven't already written that down in your notes from the last example, to solve it has to equal 0. So I'm going to move these terms over. I'm going to subtract x from both sides. I'm going to add 5 to both sides. That's going to give me 0 equals x to the 3rd plus 3x squared plus 2x plus 6. Now we're trying to think about our factoring patterns again. Which group will we put this in? And if you look, this has 4 terms, so I think grouping is a good option to try. So if I group this, that's going to give me x squared, x plus 3. The other side, that's going to give me plus 2, x plus 3. So my final factoring is going to be 0, x squared plus 2, right? Those are the numbers in the front, and then x plus 3. Notice, this x plus 3, I only write it one time, remember? Even though you see it twice, it's only going to be written once. Otherwise, you're going to accidentally change the degree, because this started with a 3rd degree, and I've got x squared and an x. All right, that's going to give me 3 altogether. So now I want to solve each of these. This right here, I can write this out for you, right? X squared plus 2 equals 0 and solve, subtract 2. But as soon as you see this, you're going to notice that that's going to be not real because you're going to be taking the square root of a negative number. So since it's not real, there's not going to be any solutions out of that factor. Okay, so then this last factor, if we find solutions for it, the solution is just going to be x equals -3. And we can plug that back in just to check. That's always a good thing to do.